All right, so I think I'm recording. Let's take a look at some of these graphs where they're asking us to determine if the function is increasing, decreasing, or constant, and also if the graph has symmetry, if it's an even function or if it's an odd function. So we always want to trace out the graph from left to right. So as I start here with this arrow here, um, on this portion of the graph, I'm going up, so I'm increasing because I'm always going to trace it out from left to right. Now at this little maximum point right here, the graph changes, and I'm going to be interested in the x-coordinate of this point in just a second. Now it's changed. Now I'm going down. So on this portion of the graph, we say the function is decreasing. Then it hits this minimum, and there's another change. And then over here, as I trace it out, going from left to right, it's back to increasing. So when I see these arrows, I need to interpret them. And since I'm wanting the x-coordinate, this arrow going down and to the left, the x's are coming. As I'm coming in from the left, I'm coming in from negative infinity. Over here, as I exit the graph, the x values are going off to positive infinity. So I'm interested in the x coordinates of these max and min points. So the coordinates of this point is negative 5, 6. I'm not interested in using the 6 when I'm describing the interval, the location of where this function is increasing or decreasing. I'm only interested in using x coordinates. So down here, this point is 5, 1, but I'm not interested in using that y coordinate. So it's asking me first, I believe, for where the function is increasing, and that's where I've highlighted in yellow. And since we have two different intervals here, we're going to need that union, and we just use the u, and it means the union of two intervals, the union of two sets. And we can, when we're reading it, we can read it as the word or. All right, so let's write down using interval notation where this function is increasing. As I come in, moving from left to right, as I come in from the left, that's negative infinity. And I'm increasing, and I continue to increase until I hit this point at negative 5. Now, I've noticed that some people just jump in right away and say, okay, well, on the next part, from negative 5 to positive 5, from negative 5 to positive 5, we're going down. The function is decreasing. Then there's a change, and I'm going back up again, so I have to come back up to the increasing, and the x-coordinate is 5, and that's continuing to increase forever. It's going on, and I'm using the x-coordinate. Even though when I'm thinking increasing, I'm thinking going up, but to describe where it's going up, it's as x approaches positive infinity. So now I need to identify if there's any symmetry in the graph and identify this as an even, odd, or neither function. So I'm going to erase this so I can see the graph a little bit better. All right. Well, I can immediately see that it's not an even function, because if it were an even function, then the left-hand side and right-hand side would be a mirror image across the line y equals x. This would be the mirror. So this part on the left here, we would have to see it come over and be reflective, be a mirror image of each other. Or the part on the right here, this coming down and going on, I don't know if I'm just sketching it kind of fast, would be a mirror image. If this weren't here, if it's a mirror image across the y-axis, then it's an even function. But see, we don't have that. And I think that's pretty easy to see. So I know that I'm writing in white. You can't see that. I know by inspection that this is not an even function. Now, is it an odd function? Well, with odd functions, you have symmetry with respect to the origin. If you rotate this 180 degrees, every odd function is guaranteed to pass through the origin. Okay? If I spin this graph, if I put my pencil on the origin and spin it 180 degrees, the whole graph is now below the x-axis. Well, originally it was above the. It's not the same graph. But like I say, it's even faster than that. I don't even have to spin it as soon as I notice it's not going through the origin. If it's not going through the origin, then it's not odd. So if it's not an odd function, if it's not an even function and it's not an odd function, then we just say it's neither. Now that doesn't mean that there's no symmetry in a graph. It just means that the symmetry is not with respect to the y-axis and not with respect to the origin. There may be other symmetries, but even and odd, even is symmetric with respect to the y-axis, odd is symmetric with respect to the origin. I'm going to go ahead and do problems 1 through 4 on the same video because it's all the same idea. Alright, so here's problem 2. It's not numbered here as 2, but this was problem 2 on our test turn study guide. Just like before, I'm going to start on the left and I'm going to move from left to right. So as I start here, I'm going up, so I know that the function is increasing. And it's continuing to increase until it hits this maximum point where it changes. See, it's always changing at its max and min points. These are the points of interest that we have in the graph. We know that things are going to change at these points because now you can see that I'm starting to go down. So on this portion of the graph, it's decreasing. But then there's a min there and it turns and it changes. It starts going up again. So it changes from decreasing to going up to increasing. Then it changes again and now it's decreasing. And then it changes again. And now it continues to go up forever off of the graph. Okay? So to describe the intervals over which the function is increasing or decreasing, we only use the x values. We use the y values to determine, hey, the y values were going up. Here the y values are going down. Here the y values are increasing. Pick 2 points and you'll see as x increases, y increases. Alright, so let's describe where it's increasing and decreasing. So it starts out here, and remember this arrow gives us 2 pieces of information. Information about x and information about y. So I know I'm coming, as I come in and move from left to right, I'm coming in from negative infinity. And I'm increasing until I hit this point. I'm only interested in the x coordinate of that point. I'm not interested in the, well, it's not even, it's like 8.5 or whatever. But I'm only interested I'm not even interested in that y coordinate. I don't want to make they think that's an x. I'm just not interested in it. So the -6 is what I need. Or, well, see, now I'm decreasing, but then I come back to increasing here. So the x coordinate here is -2. I don't care about the y coordinate, you know. And then here the x coordinate is +2. I don't care about the y coordinate. So from -2 to +2, from -2 to +2, look, that as you go to the right, you're increasing. The function is increasing on this interval. So it's increasing on this interval, or you're increasing on this interval, or you're increasing, the x coordinate here is 6. At this point, I don't care about the y, 6 all the way to infinity. So now, decreasing. Well, let's come back up to our points here and let's describe where we've shaded it in green, where we were going down. We were going down, and we need a small number, comma, a larger number when we write these intervals. This does not mean plot the point -6, comma 2. This means when x is between -6 and -2, all of these x's between there, all the coordinates, all the points that have coordinates, x coordinates that are between -6 and -2, those y coordinates are going to be decreasing. Or if we're from x equals 2 to x equals 6, if we're on the graph, then those y coordinates are also decreasing. So you're decreasing here or you're decreasing here. So now we've covered everything that we've shaded. We're done with our increase. It was never constant. Okay. Now we want to determine whether this function is even, odd, or neither. So let me erase this stuff on the graph so I can see it a little bit better. You can pause the video if you need to look at the coordinates of those points. And maybe I should double check. I'm doing this kind of quickly to make sure I don't make any silly sign errors or read off the coordinates wrong. All right, so I can definitely see this is not an even function because with respect to the y-axis, with respect to this axis, the right-hand side and left-hand side are not mirror images of each other. This guy is going up like that. Well, it would need to be going this. It would need to be a reflection there to be even. Instead, it's going down like that. It is not an even function. Okay. So is it an odd function? Well, it's not a guarantee. It's going through the origin, so it passes the first test. Let's write down not even. Is it odd? Well, it is going through the origin, and when I rotate it 180 degrees, I get the same graph. Okay, so how do I know that? If you pick any point, it doesn't matter what it is on the graph. Let's say this point's easy to read, 3, 2. Then the opposite of 3 and the opposite of 2 will be on the graph if it's an odd function. So -3, and then go down, hey, -2. And it's not only true for that point, but it's true for every point. Any x, y that's on this graph, the opposite of x and the opposite of y are also on the graph. This guy is an odd function. It has symmetry with respect to the origin. Like I say, if you put your pencil on the origin and then rotate it 180 degrees, you get the same graph. All right, so let's look at the next one. All right, so let's come in. When we're doing our increasing, decreasing, let's always trace out the graph from left to right. So I was using, here it's decreasing. I was using green before. And then it hits this point and it increases. And then it hits this point. So you can see the changes are occurring at these max and min points. So now it's decreasing because I'm going down. I'm always tracing the graph from left to right. And now I'm going up, so it's increasing. Then I'm going down, so it's decreasing. So it's increasing where I've highlighted it in yellow. Now, let's come in and write the x-coordinates of these points. This has an x-coordinate of -8. This has an x-coordinate of -3. This has an x-coordinate of +3. This has an x-coordinate of +8. Okay, so it was increasing where it's yellow. From any point, any 2 points in the shaded region, as x increases, y increases. So all the way from this point that has an x-coordinate of -8 all the way to that point, which has an x-coordinate of -3, that function you were going up as you traced it out, so it was increasing. Or if you're from this point, which has an x-coordinate of +3, all the way up to this point, which has an x-coordinate of +8, as you trace out the graph, you're going up, the y values are increasing on that portion of the graph. So that's where we say that this function is increasing in these two intervals. Now what about decreasing? As you come in from the left, you hit this arrow. Well, you're coming in from -infinity. So there isn't a true number. This is just kind of an abstract concept. You know, as this is going way out there, as you zoom out from the graph, this is going to the left, but it's also going up. Well, going out to the left tells us, hey, that when we move from left to right, that we're coming in from -infinity. And we're going down, the function is decreasing until we hit this minimum point that has an x-coordinate of -8. And then from -8 to -3, we saw it was increasing. Then it changes again. So from x equals -3 to x equals +3, if between those 2 points, if you're on the graph, as you move from left to right, you're going down. The y values are decreasing. And we see that there's a third interval, or here's the x-coordinate 8, and this guy is going off. As you move to the right, as you're going down, you're also moving to the right. I'm only interested in what the x's are doing here, and I'm going off to positive infinity. And it's always a small number, comma, a larger number. So there's where this function is increasing and decreasing. Now, what kind of symmetry do I have? If it's symmetry with respect to the y-axis, it's an even function. If it's respect to the origin, it's odd. If we don't have either one of those symmetries, it'll be neither. Well, again, I can see that it's not even. Okay, with respect to, if this were the mirror, on the left here, you've got this peak. Well, its mirror image would look like that. You'd have a big M, and we don't have that. Look, it's going down. So I know that this is not an even function. Just by inspection, I can see that it's not even. I do not have symmetry with respect to the y-axis. Well, what about the origin? Hey, it is passing through the origin, so it's passing my first test. And what about if xy is on the graph, is the opposite of x and the opposite of y also on the graph? Or maybe easier, does it have rotational symmetry with respect to the origin? If I rotate this graph 180 degrees, I don't know why the point went off there. Maybe I should move that. You can see that it's the same, right? This was going down, that was going up. Well, let's see if I can undo it. Yeah, it went down and then up. So, if 3, -4 is on the graph, then for every xy, what's the opposite of 3? Well, -3. What's the opposite of -4? +4. Hey, that's on the graph. And that's true for any point that I pick. I'm just picking points that are easy to read the coordinates off of. 10, 0. The opposite of 10 is -10. The opposite of 0 is 0. So this guy is definitely an odd function. It has symmetry with respect to the origin. When we rotated it 180 degrees, we got the same graph. All right, so let's take a look at this problem number 4, which is the last of these increasing, decreasing, constant, and even, odd, or neither. So again, we're tracing out the graph as we move from left to right. So as I'm moving to the right, I'm going down, so that's decreasing. Hey, I hit a local minimum, or these are minimums, these are maximums, this is a minimum, and we know at mins and max it changes. So instead of decreasing, now it hit its minimum and I'm heading up towards a maximum. It's increasing towards the maximum. Now it's hit its maximum and it's changing and it's heading towards a minimum. It's decreasing the y values because y controls up and down. And now once I hit this point, I'm going back up again. So let's give myself a little bit of room. Where is this function increasing? To determine the locations, we only use the x-coordinates. So I need the x-coordinate of this point because I've made yellow. I've tried to be consistent, and each time I've shaded in yellow, it was increasing. So this x-coordinate is -4, if I'm reading that right. This is going through the origin, which is 0, 0. But again, I'm only interested in the x's. And this is +4. And it looks like -8, but who cares? I'm only interested in the x's. So where it's increasing in yellow, it's starting here at -4, and you're going up, 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 up until when you hit the point that has x equals 0, and then you start going down. So it's increasing on this interval or on this interval, which starts here at 4, and you're going up, 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 and you're going up forever. You know, as I go up, I'm moving out to the right. So 4 to positive infinity. Now, where is it decreasing? When we came in from the graph, we came in from the left. Coming in from the left, extremely far out to the left is where negative infinity lives, right? And as we trace out the graph, as we're drawing it from left to right, we're going down. And if you're going down, the y values are decreasing. That continues to happen until we hit this point that's a minimum, and then it's going to change. So all of a sudden, when x equals -4, it changes and it starts increasing from -4 to 0. But then here at the origin, here when x equals 0, it starts going down again. So, or if you're in this shaded region where it's in green, or if you're in this green region, which is from 0 to 4, see the points on the graph that have x coordinates that are between 0 and 4 are right here. And as you move, as x increases, the y values are decreasing. That's how I know it was decreasing function. I was going down as I traced it out. All right, so let's determine, that's our answer now for increasing. It was never flat. It was never constant. So do we have symmetry here in this problem? Well, it is going through the origin, but if you rotate it 180 degrees, this kind of looks like the shape of a W. And if I rotate it 180 degrees, it kind of looks like an M. So I know it's not odd. But hey, is it symmetric with respect to the y-axis? Well, it looks like it is. You know, if this is the mirror, this guy is going down on the right-hand side, and it's going down to -8, to that point 4, -8, and then it's turning and passing through 7. Well, this is going down to -4, -8, and it's passing through -7. So the x values are, the y values are the same, but the x values are equal and opposite. This one was x-intercept at +7, and over here at -7. It was a mirror image of each other, so this is definitely an even function. And it can't be even and odd at the same time. So as soon as we declare that it's even, we know it's not odd and it's not neither. You know, like I say, you fall in exactly one category. So I hope that helps. These are the first 4 problems, and I'll move on to the next set.